All right, so it's 10 a.m. We all were out late last night. So let's wake up, because we're here this morning, and this is going to be super fun, and this is going to be great. So we're really excited to be here. My name is Russ. This is Eric. We're both from Shopify. And we're all here these few days because we all know that AR and VR are creating wild new possibilities in lots of different industries, but particularly commerce, and that's where we focus our time, thinking about how these technologies affect merchants and shoppers. We're part of a team at Shopify, kind of a labs team, exploring kind of what the future holds for commerce, helping merchants take advantage of this next paradigm. We also kind of partner with platform developers to unlock commerce use cases for the new kinds of platforms that they're building. And whenever new hardware or APIs arrive, we want to be kind of the first boots on the ground, picking that technology up and seeing how that stuff might apply to the world of commerce, to merchants, to shoppers, and everyone in the ecosystem. We formed the team earlier this year we're fairly new to Shopify, but we're working with one of the longtime veterans there who's been working on AR and VR for a long time, Daniel Beauchamp. When we began and partnering with Daniel, we really wanted to push the limits of AR. And one of the things that we've run into time and time again, especially in the interior design and home space, you want to try that couch in your room with AR, but your living room is already full of furniture. So it's kind of hard to get that in there and kind of avoid all the things that are currently in your space. There are solutions around diminished reality that let you kind of remove one object from a real scene using essentially in-painting techniques. But there's still a lot of stuff in that room, and we wondered, could we actually create an experience where you could erase everything in your room at once and start fresh? What if your room had a reset button? At the time, Apple had just released the Room Plan API. This was an API and a scanning experience, like an actual UI experience, that developers can use to help their app users create a 3D model of their room in seconds. Applications are pretty wide-ranging across construction, material planning, AR previews for interior design materials, et cetera. The really cool thing about this API, I'll back up here. There's no video. Let's try this again. Oh, great. OK, cool. So it captures the doors, windows, and archways of your space, as well as room-defining features and furniture like bathtubs, desks, refrigerators, couches, et cetera. And so we thought this might give us a really good head start. If we could overlay this model that Room Plan produces over the real world at a one-to-one scale, perhaps we could essentially erase everything in your room at once. So we imagined a mobile app that could scan your space using Room Plan, identify your walls, floors, doors, windows, as well as all of the objects in the room and their orientation. And then once modeled, you can select anything and everything in the room and immediately remove it from that virtual model. And this will be overlaid in real time over your real-world scene. Or you could try entirely new living rooms, right, using the same object information and orientation information to place everything correctly on the fly. You could also select a specific object and swipe through new options for that. So this was a few little concept video demos we came up with, but we wanted to actually try and build this.
Yeah, so Russ said Apple had just released Room Plan. We were really excited to get our hands on it. We thought, we're going to have this great 3D model, and we're going to be able to use it for all these things. And what we pretty quickly realized is that it's not necessarily a 3D model. It really is a room plan. And that's great for, like he said, there's great features with that where you can ask it for where are the doors, where are the walls, where are all these different features. But what you don't necessarily get that you might get from a 3D model is texture information, lighting, things like that. As well as we also found you don't get floors or ceilings. So we basically really quickly built some polys for the floors and the ceilings dynamically and figured that all out. We also found that it's hard for computers to really infer the orientation of a room. We have an intuitive understanding of what the forward direction of a room is, but a computer doesn't necessarily know that. And so what we found that how ARKit deals with this and how Room Plan deals with this is it treats your starting direction, where you start, as the forward direction, and it anchors to that. And so the way we dealt with this is whenever we saved out a room plan, we also saved out an AR world map. And that allowed us to reconnect and relock to the world and reorient. And that was our real Rosetta Stone that allowed us to do that. However, we really wanted to figure out a solution for was textures. How can we get textures on this room plan? And so we did a really quick mini sprint, and we thought of a bunch of different ideas on how we could do this. And what we settled on was this concept of inverting the graphics pipeline. So normally, you would read from a texture, blend it, and write it to the screen. But we had the ability to flip that and read from the camera and write to the texture, and then flip back and read from that again. So we wanted to see, is this crazy? Could we do this at all? Is it possible? Could we hack this together? And so we built a rudimentary prototype in SceneKit, and we used some crazy hacks to do it. You can see there's problems. We didn't really get it past the finish line. But it demonstrates that this is possible. It's possible to do this. You can use the alignment of the room to help with these things. But we really wanted to short-circuit that process and jump forward to the future where these auto-texturing tools are available. So we asked our very talented designer to handcraft some textures, and they worked absolutely incredible. When we actually put it in real time in the iPad, it absolutely erases the room, and you can actually start fresh. And once you have an erased room, that's really when you can let your imagination go wild and start adding new things to it. This is all running in real time on an iPad with today's SDKs.
Yeah. So just pretty incredible what you can build with Room Plan today and a little bit of kind of smart texturing. So we're really excited to see kind of where they continue to take Room Plan. And you know, as we continued exploring AR, you know, we wanted to continue pushing on those limits, right? And one of the things that has frustrated us working in the space of interior design and AR is that you can't sit on a virtual couch, right? What is the most important thing about a couch? How it feels to sit on. And so we wondered, what about AR in reverse? Instead of bringing your shopping home, what if you could bring your home shopping? So we all know AR, right? You put a virtual thing in your real room. Reverse AR is putting a virtual room around a real thing. So you can sit on that couch and see it in your room at the same time. Here's how something like this might actually look in the real world. This is a concept video we put together. Here's Eric and another friend of ours. They're in a vintage furniture store checking out some stuff. They found a couch that they really like. Eric's going to engage his AR glasses, and the room that they've scanned at home suddenly unfolds around that piece. And our friend Rune here can sit on that sofa, touch that sofa, and yet look up at the same time and see himself in his home. If he doesn't like the position, you can use natural gestures to reposition the room around the object, finding just the perfect spot for it. And then you can watch virtual Netflix in the store. Or maybe not.
So we moved on to the next project, which basically was, or continuing on this project, we wanted to find a way to segment that particular chair or that particular object from the room. And so the first thing that we tried was the meshing capabilities that were available in AR Foundation. And we found that while it was actually a great starting point, it wasn't actually quite enough. There were parts that were missing. There were holes in the mesh, and while it was a great starting point, it didn't quite get us to the level of fidelity that we'd like. We did end up using these meshes for shadows that we could project on the ground, but what we found was that by using the depth map that we get from the environment and using a bounding box to really hone that in to figure out exactly what area we want to keep out, we can create a really, really good mask. And using that mask, in real time, we can cut that part out of the scene and fill in the scene around it. So here's a working prototype we built. This is, again, this is all running on iPad Pro in real time using today's technologies and SDKs. We really wanted to make sure that we weren't putting anything out there that wasn't possible. So this, and I gotta say, watching this in video is one thing, but when you actually pick up the iPad and you're moving around and you kind of like see the other environment around you and it's all happening in real time, the experiential difference is really up there. And so I gotta say, there's something about actually having this experience in hand that's pretty cool.
Yeah. Yeah, we can't wait for AR glasses and other pass-through headsets to arrive. We've got our Quest Pros coming on Tuesday, so we're excited to start playing around with those. Now, while we were exploring all of these really interesting things on the AR side, which is sort of our bread and butter, it's what we've been doing for a few years, this revolution in AI was starting to take off, and we were taking notice. We were getting really excited about the possibilities with generative art and AI. And so we started to think about, well, how will AI and AR overlap? These two things are actually quite complementary. And we realized that sometimes, when you're searching for something really specific that you want to buy and you're having trouble finding it, in those moments, could AI actually step in and create something for you on the fly and make every shopper's wish come true? As I mentioned, text-to-image tools are making it possible to generate custom art and patterns using just a description. We generated this using DALL-E 2 with the prompt hot dog wallpaper pattern. This technology, generative AI, plugged into on-demand printing and production, will actually make it possible for shoppers to ask for something and order it immediately and get it. So we wanted to prototype what this near future might look like using some of these technologies. And so we brought together voice user interface, live AR previews, and generative AI to build something sort of resembling a product Wallpaper Genie.
Okay, computer, I'd like a corn-themed wallpaper. No, corn on the cob in a tiling pattern. Yeah, okay. Need something else to make it interesting. Let's stylize it and add some pink flowers. Yeah, perfect. Can we make it bigger? Yeah, great. Cool, let's buy it.
Boom, buy now, gotta love it. We also realized this works for apparel too. So we used the SceneKit SDK to do some shirt segmentation using the same underlying AI technology.
Can I get a raccoon here in space? As a painting? In a Hawaiian shirt with sunglasses, eating a pizza. No, here. Perfect.
Yeah, so one of the earliest things that we did in this project was we found a way to create animations out of these diffusions. And the way we did that was by saving out a predicted final frame after every step of the diffusion process. And by doing this, we create this really cool animation. And we just found this fascinating, so we wanted to include that in the demo. But we found, once we moved past the fascination phase, we really found that prompting is very challenging. So if you notice here, these are some mistakes, some things that didn't come out quite right when we asked for corn. If you look at it closely, it just really doesn't make any sense. And actually, I diffused about 750 different corn videos before finding one that worked in our final thing. So we found that it's a challenging thing to actually get prompts that work very well and get the exact thing you want. In fact, when we were doing the raccoon floating in space eating pizza, we diffused a bunch of different options and found that often it would drop one or multiple of the terms, and we had a really hard time sort of focusing it on what we wanted it to focus on. However, we were running into these problems at the same time that a lot of the community was running into these same problems. And during the course of our sprint, a feature called composable diffusion landed in a lot of the repos we were using that allowed us to really get past that finish line for this particular project. There's still obviously a lot more we can do with that, but it was incredible to see that there's these advancements happening while we're working on this project itself. In fact, last night, Stable Diffusion 1.5 was released. So this is happening all right now. It's all happening very, very fast. It's very exciting too, because actually we'll talk about a follow-up project later.
Cool, not just yet, Eric. So yeah, I mentioned Quest Pro. We've got ours arriving Tuesday. We're super excited to dig in there. With this new sort of generation of business-focused headsets arriving, it got us kind of thinking about what the future world might look like for merchants in about 3 to 5 years. Virtual photography in particular is an area that's really interesting to us, right? It melds a lot of the things that we're thinking about, 3D content, how to create virtual worlds. Virtual photography is really powerful for merchants because instead of spending $30,000 on one photo shoot, they could potentially spend that same budget on models for every one of their products and then essentially create infinite product images from that. It turns out, actually, and we've all probably experienced this, building 3D things on 2D screens is pretty challenging. But AR unlocks 3D computing in the real world with natural hand interactions. So we wanted to start to play around with some of these ideas, thinking about the future of merchant work and merchandising, and wondering, could AR glasses actually revolutionize productivity?
Yeah, and this was a sprint where we kind of wanted to do a little bit more exploration and finding out of different primitives before we brought it in together and into a product or a demo we wanted to share. And this was a project we spent a little bit more time in AR Foundation. We really explored the concept of slices, reality slices that Unity's talked about and other people have talked about. I'm happy to report that it's a lot easier to build a performant version of this now. It's a lot easier using URP features and using some stencil buffer stuff. It's a lot faster than it used to be. But what we found in playing around with this stuff is it's cool to switch between these different reality slices, but we wanted to zoom in on one and really focus on one and what that would look like. Then we started experimenting more with the Oculus Interaction SDK, and we found that it actually has a lot of baked-in wisdom, and a lot of the stuff that it promotes around physicality and the skeuomorphic interactions that it promotes, we found that they're actually pretty impressive and they're very good. And there's a lot of magical interactions that happen from those things. So at first, we had the idea to lean into that. And how far can we go with this skeuomorphism? And how far? So we built these cameras that you could summon with a gesture. You could take use another gesture to take the photo. It would output an actual physical Polaroid that maybe you'd be able to put into the website. But we found that over time, it was hard. First of all, it's hard to discover those features. It's also hard once you've taken a bunch of photos and there's kind of clutter around. So we've started thinking, how can we bridge this gap? And the skeuomorphism is great, but also there's some problems with it as well. So we developed some other techniques. We have developed this idea of the primary controls being visible, but when you reach for them, sort of ancillary controls come out, and the complexity reveals itself when you actually reach for it. And so this ended up being a great, we called this proximity controls, and this ended up being a great unlock for us. Another unlock for us was we were thinking a lot about, okay, in the workspace, you often have a desk in front of you. And what can we do with this primitive, with this surface that everyone seems to have in front of them? And one of the things that we tried exploring was what happens if you put the UI on that surface so that when you touch down, you actually feel it. When you scroll, you feel that tangible response. And this ended up being another major unlock for us because we really felt the experiential improvement.
Yeah, and after playing around with all of these ideas, we kind of brought sort of the best of them together and wanted to kind of visualize with a full kind of end-to-end prototype. So this is running on a Quest 2. This is all on device. I've got my spatial admin here on top of my kitchen counter. I can open a piece of media from my website into a 3D virtual studio. I can change that product to something else. I can reposition it in the scene. I can change the scene around it if I want to something completely different. I can also change the color and intensity of the lighting set up for the scene and reposition those to get just the right shadow cast and color glints off the shoe. And then as I move the camera around, you can see that it live updates the media on the site. Now this is just a preview. Of course, I've got to save this out and make this live. So here we go, using those natural desktop interactions. Big finish. Cool. So, while we were exploring the future of merchant work, AI kind of continued its breakneck pace of innovation. And some techniques arose that allowed us to teach generative AI new kinds of concepts, new concepts for objects, new concepts for styles. And we wondered if we could teach it how to render a product in any scene. Could AI actually unlock unlimited product imagery? So we used Dreambooth, and we trained it on 20 to 25 images of these products that the team had in their homes. We really just took these on our phones. We used our iPhones, took them in various scenes, various positions, angles, zoom in, zoom out, and fed these into Dreambooth and trained it on an A100 for about 1.5, 2 hours, about 4,000 steps. And here are the results. So you see on the left, this is our training image. And then the grid on the right are all of the images that Stable Diffusion was then able to produce with the model that we created for this shoe. We took it, and all of these results are actually no post-processing. So these are direct outputs of Stable Diffusion. If we were to take these into some form of post-processing, I think you'd see even more impressive results out of here. But we found that products with kind of simple forms and organic lines reproduce exceptionally well. For example, we took this running shoe on adventures across unfamiliar terrain. And we gave our very humble home fashion shoot a major upgrade. We were able to call in different models, different body types, different locations, different times of day, different lighting. all using just this one training set. And we took our mid-century Eames lounge on a tour of some Bond villain HQs in some beautiful remote locales like the Arctic and Arches National Park and some kind of Scottish lake, I think. And then, of course, Big Bear, which is my daughter's favorite stuffed animal, finally got a chance to showcase his holiday versatility. Here he is at Christmas and Halloween and summer and springtime. He's a bear for every season. Of course, AI can also generate really expressive outputs, so not just photorealistic imagery, but also expressive images for ads and other creative applications. But, of course, there are some limitations. We're showing you the best of. Now, we probably ran hundreds of diffusions for each of these products and then culled the best. But it was still just a couple hours of work. And imagine comparing that to setting up a whole photo shoot and the costs and time associated with those kinds of things. The savings are wild. So this technology is incredibly promising, but here are the limitations that we saw. Text, geometry, precise details, precise machined details, where numbers matter, how many fingers you have, how many arms you have, often called into question with Stable Diffusion. So those things tend to get a little bit warbled. But as I mentioned, things with organic lines, similar textures across the object seem to do really, really well. And of course, as Eric mentioned, this technology is improving by the day. So we are keeping a very close pulse on what's happening here.
Yeah, I don't think this is the final state of the technology, but it seems like right now you have to pick two of these three things. You either get a cohesive product that looks like the actual product, you get a great photo composition where it's centered in the frame, and the other option is that it's blended into the background properly. We found that oftentimes we'd get like a great subject background blend and great product cohesion, but it'd be cropped off to the side, or it'd be centered perfectly and it would look exactly like the product, but it would look cut and pasted on top of it, or it would have 3 arms like Russ said. So we found that a lot of times it's sort of pick two, and also the end result of a lot of this is that you kind of just have to try a lot more times until you get what you want in the current state of technology. But towards the end of this project, we started doing some more interesting research and on what we could do on the combination of all these things. And so this is actually a path forward we trained 2 separate models with Dreambooth. We were able to combine the weights and do combinatorial merges of these things. So we scanned a bear, we scanned a sweatshirt, and then we were able to create the bear wearing the sweatshirt. And the way that we found to do that is by making sure that you encode it into different tokens. So a lot of Dreambooth often tends to encode into the same token, but we found if you just use different tokens, you can merge these weights. So we're very excited this is just like a glimpse into the future of how these things can go. We're starting with combinatorial stuff, there's Dreambooth stuff, but what's happening is it's expanding into 3D, it's expanding into XR and AR, and we're very excited to see where this goes in the next few years.
Yeah. Well, thank you. That's it for the projects that we have to show today. Oh no, wait, go back. There we go. Can I get it back on the monitors here for the notes? Anyway, we are a team that works in 3-week sprints, so we are constantly staying kind of at the front breaking edge of the wave of technology and seeing how those things apply to commerce. So we are, we're back at the beginning. Could you zoom me to the last slide? So we are excited to chat with everyone here about the APIs and SDKs and hardware and platforms that you are building, because that's why we're here. We're here to take those new things and hopefully light the path for merchants, for shoppers, as to how these technologies are going to be used in the future in retail. So follow Eric and I on Twitter. We release all of our work via Twitter every few weeks. So if you want to see future projects, follow along. I'm Strange Native.
I'm Eric Flo.
Cool. Thank you, everybody.
Thank you so much, Russ. Thank you so much, Eric. You did show us superpowers. Oh, I'm so amazed. We have time for a few questions. Anyone have a question? There?
In the first demo that you showed, can you use Room API in Unity, like to show in IR also?
It's relatively easy to export it to a USDZ, and so you could use that and convert it. You could bring it into Unity. Once you have that USDZ, you can really use it in a lot of different places.
But as we mentioned, the model that RoomPlan outputs is completely untextured, has no floor, ceiling, polys or shapes. So it's sort of a, it's a kind of a half-complete room model. Yeah.
Thank you. Then the next one.
If there's a machine learning library that you prefer, which one is it and why?
I don't have a preference. We use PyTorch for a lot of the Stable Diffusion stuff because that's what it's written in. I know there's a TensorFlow implementation. I tried it. It's fine. I don't have any big preferences, so no.
Just checking the time. We have time for another question.
There's one more over there.
There you go.
Do you have any insight as to whether Apple's AR glasses will support ARKit, SceneKit, anything like that? How much, as an ARKit developer myself, I'd like to know how much potentially could be reused on their imminent yet delayed goggles?
I don't have any insight. I will say that we ran up into some things like that too. I think I mentioned that in one part we switched over to SceneKit to try some hacks and make things work. So I think there's some interesting areas where there's not 100% coverage across all the APIs. So it'll be interesting to see how that develops, but I don't have any insight or knowledge about that. But we did run into some things around that.
Yeah, short.
Is it possible to try out the room reset feature? Do you have a test application?
We don't have a test application at this time. As we mentioned, we did all the texturing by hand. So that was custom designed for the room we launched it in. In order to launch something like that live, we'd want to probably figure out that auto texturing situation to make everybody's room look great.